Hey folks, we're going to look at continue on with kinetics and looking at rates of things and how different processes can have different types of rates. And what we're going to start thinking about is, do all processes change the same? So the first process I'm going to look at is a container of pennies. If you imagine, you can try this at home if you want to, but you can take 100 pennies and put them into a container. And you take every penny and make sure it's all heads up. So now I know this picture is not totally accurate, but pretend every penny is heads up. And then you take the pennies, you cover it, and you shake it violently like this. Shake it around, get it all shook it up. And at the end of all that, what is the number of pennies that should stay heads up? So if probabilities work out, roughly half of them should stay heads up, half of them should be tails up, and that would be 50 pennies. Okay. So if I took the pennies now and I removed half of them, so I only take out the tails up pennies. And so I keep the heads up in there. I remove the tails ones, said, okay, well, those are gone. They have gone away. And now I do the same process again. So I take the 50 pennies and I heads up, cover it, shake it violently, shake it. And then how many pennies should now be left heads up? And if you are thinking about probabilities, about half again. So half of them stayed heads up. The other half have now gone away. Their tails up. So I'm going to take them away. And we keep doing that until all the pennies are gone. And what you can see happening is that I start with 100, I get down to 50, then I have 50, I go down to 25. 25 goes down to about 12. You can't have a half a penny. So 12 and so on until you're left with 0 pennies left. Okay, so that's one process. We just keep decaying and going down over a period of time until everything is gone. So that's process one. We're going to look at the data for that. Process two is burning of a candle. So let's say I have a candle and I put it on a scale and I weigh it. Okay, so the candle weighs a certain amount, and then I light it on fire, and then I start weighing it over a period of time. What will happen to that mass of that candle as it keeps burning? Well, as we should know, the candle is going to burn and change to gases, carbon dioxide, water vapor, and as it does that, it's going to lose mass. And so I have a video of me doing this, and I'm not going to make you watch the whole video because it's rather long and tedious, and I literally sit here and watch a candle burning. So not many people have watched this video, but if I start at 0.70 grams, 0.70 ounces, 0.070 ounces, and I let it keep going every minute, I just keep watching the time tick away, and I have the mass, just keep tracking it over a period of time. You can see the mass is going down. So now we're down to 0.060, 0.055. And we keep doing this over a period of time, and what will you see? Well, the mass is going to drop. Okay, so we start at 1 minute, 0.070 ounces, and then we just keep going down, go down, go down. And so what we're going to do is compare these two sets of data now and see what's the differences of how these two things are decreasing, because they're both decreasing, but how is it different from each other? So this is the data for the shaking of the pennies. As you can see, we have the shake number goes from 0 to 7. We start at 100. And we drop down by half every time. So it's cuts in half, cuts in about half, and so on. if I were to graph this, let's take a look and see how this would graph out. So I have, grab my pen. So at 0 shakes, I start with 100. And then at 1 shake, I cut down to half, so it's about here. And then the next one is 2 shakes, is 25, so it's about here. 3 shakes is 12, so it's about here. 4 shakes, 6, and so on. 5. Okay, if I look at the data here, the question now is the rate the same for if I started at 0 versus if I started here versus if I started here? So is the rate the same or different based on which shakes we look at? Okay. And, well, if I look at the beginning and I take a slope of this slope here, if I were to measure from here to here, how would that slope compare to here? And I think you can see they're not the same slope. So the slope, or the rate, changes over time. It gets less and less. So depending on whether I look at the first 2 points, or the second 2 points, or the third 2 points, or so on, that's going to be different every time. Well, what if I look at the candle burning data? So the candle burning data, I start at 1 minute. It was 0.070 ounces. 2 minutes, 0.065. 3 minutes, 0.060. 4 minutes, 0.055, and so on. So if I'm graphing this out, it's going to look like, well, at a minute, I'm going to start at a minute because that's what we did. And then it goes down to 0.065, 0.060, 0.055, and so on. Does this rate depend on where we start? So does this rate, the rate of decay, depend on where we start? And let's take a look. Well, if I look at these 2 points here, I have that rate. Well, these 2 points, these 2 points. So you can see here, this is a straight line. It doesn't matter where we start on this graph. I take minutes 1 to 2, or 2 to 3, or 3 to 4. If I'm burning this candle for 10 minutes, that rate, if the candle is the same width the whole way, is going to burn at the same rate. So what we're going to look at now is we have different processes taking place. This process here is a specific kind of process. This process here is a specific kind of process. And what we say for this one, because the rate does not depend on where we start, this is called a zero order process. So zero order process means that the rate does not depend on how much candle we have or the concentration of the candle. Okay, so the rate does not depend on the concentration of the substance. Well, in this process, it's different. Because the rate does depend on this, it's not a zero order process. And this actually ends up being a first order process, and we'll talk more about what first order process means. But this is a first order process. And one of the characteristics of a first order process is that it has something called a half-life. So a half-life is where every cycle, the amount of something decreases by half. So this has a half-life, and every cycle of something, so this is a shake for this instance, I'm cutting it by half, I'm cutting it by half, I cut by half, and it's the same time every time. Okay, so we will talk more about what these two processes are and how we can tell them apart.